Okay, so we are continuing our recap of Chapter 3, and this will be the last one, and then we'll be caught up. So this is recap part 3. The other two set operations we want to be familiar with are the Cartesian product of two sets, and usually we say A cross B when we want to refer to that. Instead of always saying the Cartesian product. And that's just all ordered pairs where the first element or the first component comes from the set A and the second component comes from the set B. And then the second one is the power set of a set. So if you start with the set A, you look at all possible subsets, and then you put that those subsets as elements of a set. We'll look at examples here on the next slide. So let's say we want to look at number 1 here, A cross B. Well, then we're looking at all ordered pairs where the first element comes from A. So let's start with 2, and that gets paired with every element from B. So it would look like that. That would be 2 elements in this set. And then we also have 3 as an element of A paired with all the elements of B. And then we also have 4 as an element of A, so that's the first component, paired with the elements of B. Right, so that would be the Cartesian product. And we'll just look at a couple of these. So we'll look at the first one, and then let's look at the power set. So what's the power set? Well, you look at A, and you look at all possible subsets. And I like to do this in order, starting with no elements at all. So there's always the empty set. And then we have the single element sets like 2, we have 3, and we have 4. And then we have the 2 element subsets. So 2, 3, 2, 4, and 3, 4. And then we have all of them together. 3 elements. And as soon as you get to all the elements, you're done. So that would be the power set of A. And notice that this is actually asking how many elements are in each of the following. And so you'll see that in number 1 there, we end up with 1, 2, 3, 4, 5, 6, right? So we end up with 6 guys in there, 6 elements. And down in number 4, we have 1, 2, 3, 4, 5, 6, 7, 8. And it turns out there's actually a nice formula for that. If you want to know how many elements are in A cross B, it's how many elements in A multiplied by how many elements in B. So in this case, we would get, what, 3 times 2, which is our 6. And for the power set, there's also a nice one. If you want the number of elements in the power set of A, that's equal to 2 to the number of elements in A, which in this case you'll see is 2 to the 3, or 8. Right. So those formulas hold in general. And the last thing we want to look at is the partition of a set A. Instead of looking at all the subsets like we do with the power set, we want to look at just certain subsets that satisfy these 2 properties. So if we look at number 1, if we take any 2 of the subsets that we've chosen and you intersect those, we want that to be the empty set. That means they share no elements, right? There's no overlap in those 2 subsets. And then the second thing is if you union all the subsets that we've chosen together, you'll get back the entire set of A. And so that'll form a partition, and that'll play a special role in some things that we'll do later on. If we go back, notice that we need non-empty subsets. And so that's why a couple examples here. The first two are examples of a partition. So notice in number 1, for example, if we take any two of them, like say the set 1, 2 and the set 4, 3, take the intersection, that's the empty set, right? They don't share any elements in common. If you union all 4 of them together, you'll get the set that contains 1 through 6 back again. So that's a partition. And we did these in class a few weeks ago. If you look down and say number 3 here, and you want to see why that's not a partition, well, you'll notice that the 3 appears twice, so the intersection between the first subset and the third subset would not be the empty set, and kind of so forth. Number 4 here, notice that this 1 here is not the set containing 1, but just the element 1. So it has to be subsets of A to be a partition, and 1 by itself is not a subset. And in 5, we have the empty set. And actually that was kind of a tricky little thing. In number 5, that wouldn't be a partition. If we just delete that guy, then what we're left with would be a partition. And that is kind of the end of what we have done so far in Chapter 3. Next we'll start with Section 3.3, and even though we did talk about that a little bit before spring break, we'll consider that kind of new material.